Good afternoon, everyone. Hope you're all having a fantastic day. A couple of things before we get going. We're going to be working with quadratic functions, writing quadratic functions today. And there are three forms that can be found with writing quadratic functions. You got standard form, which is what you're used to seeing them in, ax squared plus bx plus c. A couple of things about that. You've got, well, let me get into that in a second. You've got vertex form, which we also call transformation form. A, which is your multiplier, multiplies how big it is or how small it is, x minus h squared plus k. And then root form, which is a, x minus r1, x minus r2. So let's go through really quickly and talk about what each of them mean. For vertex form, your vertex, which is the point of the highest or lowest point on the parabola, it's where it turns around, is negative b over 2a, and then f of negative b over 2a. So basically you take this b, put it in here, take this a, put it in here, figure out what your x coordinate is, plug that into the function, tell me what your y coordinate is. And that'll give you the coordinates for the x-intercept. Or for the vertex rather. And the y-intercept is 0, c. You know that c is your y-intercept. It always has been, so there's nothing new there. Vertex form, or excuse me, that's standard form. Vertex form gives you the vertex, x minus h plus k, this h and k. Now this is really important to remember because this minus right here, oh, if you need to go in the hallway, you can too.
That's okay.
X minus h, so the minus sign in front of h, that has to be a minus for this h to be positive, because remember, we always do the opposite of what's in the parentheses. K is just positive k. So this actually gives you the vertex, h comma k is the vertex, and the axis of symmetry is h. So a lot of useful information there. Root form, a x minus r1, x minus r2. r1 and r2 are your roots, or x-intercepts, where it touches the x-axis. That's r1 and r2. So a lot of good information we can use here. It says for the function, negative 2x squared minus 12x minus 10, find the following. So first your vertex. So I'm going to use, first you need to identify what form it's in, and this is in standard form. So to find the vertex, I'm going to use this information right here. So vertex is negative b over 2a. So your x value, negative b, which is negative 12 over 2 times negative 2, which is 12 over negative 4, which is negative 3. So I found my x coordinate for my vertex. Now I plug it back in to the function. That's what this means. Plug it back into the function and find your y. So plug in a negative 3 here. F of negative 3 is negative 2 times negative 3 squared minus 12, negative 3 minus 10. And that's going to be what? You have 9 and negative 2, so negative 18 plus 36 minus 10, so 8. So your vertex is negative 3 comma 8. Found our x from the formula, plug that in for x and found y. Roots. Okay, for roots we have to get this thing into root form. And how we're going to do that, to solve for roots, if you notice, root form, you pull your a out and then you factor. These are factors of this one up here. So if you have an a, first let's pull it out. So my a is negative 2, so I'm going to pull out a negative 2 out of that function. X squared plus 6x plus 5. I factored out a negative 2. Now let's factor this, and then we're going to solve it. We're going to set it to 0. So let's set this thing up just like normal. Nothing's new here. This finding roots is something we've been doing since Algebra 1. So set it to 0, find out what your roots are. So negative 2, set it to 0. This will be x plus 5 plus 1. So divide by negative 2, that goes away. You've got x is equal to -5, and -1. So we've got two roots here. We've got roots at -5, 0, and 1, 0, -1, 0. Remember, these are your x-intercepts, so obviously your y value is going to be 0. Okay? Now for axis of symmetry. Axis of symmetry. This one is going to be a little bit different. So what I would say to do here first is to go through and write the different forms. It makes it a little bit easier. Y-intercept is pretty easy to see. Your y-intercept in this case is -10, just this last number. So 0, -10. For your axis of symmetry, it's going to be the x value of your vertex. I mean, think about a parabola. I need a post-it note. Think about a parabola. If this is your vertex, and this is x, y, whatever this x value is, that's going to be your axis of symmetry, right? So whatever the x value is of your vertex, in this case, -3, that's going to be your axis of symmetry. And now we can graph it. So the axis of symmetry is at -3, so I can go to -3. Ooh, announcements. No? No announcements? Oh, announcements.
Attention in the building.
Attention in the building.
Shayla Robinson, please come to the front of the school.
Who's Shayla?
Shayla Robinson.
I know
Your
Shayla.
parents is waiting at the front of the school.
Ooh, Shayla's parents. All right, so we have x equals -3 is your axis of symmetry. That means that the parabola is going to shift off of that. Your vertex is -3, 8. Your roots are -5 and -1. And that's all we need. Down, oops, down like that. And down like that. Good enough for me. Actually, you know what? No, it's not. It's not good enough for me. Because it gave us a y-intercept of -10. Now it's good enough for me. Whew, that is the messiest parabola I have ever drawn in my life. That's okay. All right, so standard form was actually given to us, -2x squared minus 12x minus 10, given. Vertex form, from the top there, f of x equals your a value, -2, x minus h. So this is going to be x minus -3, so plus 3, squared, plus 8. Your vertex is -3, 8. All these equations are the same. If you distribute, or if you multiply x plus 3 times itself and then distribute your -2, simplify, you get this. They're all the same. Root form, f of x is equal to -2, your a value, x minus r1, x plus 1, x plus 5. Since those are negative, now they're going to be pluses. X minus r1, x minus r2. Okay? Not too shabby. There's a lot of stuff that goes into this, but really if you just follow the formulas, it all kind of builds into itself. Your vertex, -b over 2a, that gives you your x value. Plug that in to get your y value. Your roots come from factoring it and solving it, which is Algebra 1 stuff, just factoring an equation and solving it. That's how you get your roots. Axis of symmetry is the x value of your vertex. Y-intercept is the last number in the equation. And then graph it, write your equations. Pick out the information you need to fill in for each equation. Okay, so use the given information to write an equation for each quadratic function. Write the equation of the quadratic function with roots. If it gives you roots, use root form. and then a y-intercept of negative 12. Well, that's entertaining. Let's write down root form first. Write down some information. They gave me root 1 is negative 2. Root 2 is 3. And then they give me a point of 0, negative 12. That's your y-intercept. They'll always give you a point. So roots and a point. So let's try it out here. We've got y is equal to, we don't know what a is yet, but it's going to be x minus r1, so plus 2, x minus r3, or r2 rather, 3. And then they actually tell you that it goes through a point 0, negative 12. Well, if I plug in a negative 12 for y and a 0 for x, I can come up with what a is. So it's going to be negative 12 is 2 times negative 3 is negative 6, so negative 6a. So your a value here is going to equal 2. Y equals 2 times x plus 2, x minus 3. So after I found a, I'm going to plug it back in the equation, and now I have my parabola, my quadratic. So this is kind of a process. It's all about solving for a and then plugging it back in. Alright, so number 2. Write the equation of a quadratic with f of 1, negative 1 being negative 7, and a maximum value at f of 2, negative 1. Maximum. Well, what is the maximum of a parabola? That's its vertex, isn't it? So it tells me I have a vertex at 2, negative 1. And it goes through a point, negative 1, negative 7. So let's use vertex form. They gave me a vertex, use vertex form. A, x minus 2, right, x minus h squared plus k, so minus 1. Plug in the values that you were given and solve for a. So negative 7, a, negative 1, minus 2, minus 1. Make sure if you're having any questions on these, write them down, bring them to class tomorrow, and we'll answer them. Negative 7 is, let's see, this is negative 3 squared, so that'd be 9. 9a minus 1, add your 1 over. Alright, add your 1 over and you get negative 6 is 9a. So a is going to be negative 6 over 9 or negative 2/3. Come over here, write your equation. Negative 2/3 x minus h squared plus k, which in this case is a negative 1, so minus 1. Number 3, write an equation of a quadratic with a minimum. Again, they give you a vertex. So vertex at a point 3, negative 5, and a point 1, 2. It goes through 1, 2. Let me just write that down so you don't get distracted. Alright. So let's set up our vertex format and see what we can come up with here. Vertex form, y is equal to a x minus h squared plus k, which is negative 5. Plug in your point. 2 is equal to a 1 minus 3 squared minus 5. That's going to be 2 is 4a minus 5. Right? I hope I got that right. Yep. Add your 5 over, it's 7. So a is 7 over 4. So your equation is going to be y is equal to 7 over 4 x minus 3 squared minus 5. So it's just a process of find a and solve for it. Okay, so now this one's a little bit different. It gives us zeros. Zeros at -1, 0, and 3, 0. So I've got roots. R1 is -1. R2 is 3. And it has a vertex at 8. A maximum value of 8. That's weird. Vertex at... Now, if you read carefully, it says it has a vertex value of 8. And we remember that value is y. So we've got to come up with something to get me x. I've got to come up with something here. Okay? I've got to come up with something for my x's. So that's not too hard of an ordeal. Think about this for a minute, though. Back to this. If you have two roots, let's say we have these, this is root 1, root 2. Little common sense here. The distance between root 1 and root 2 should be the same. It's going to the vertex, right? So if this was a 3 and this was a 6, well, shouldn't I be able to divide the distance between and come up with my x value? Let's use the ones we were actually given here. Roots of -1 and 3. If I was to take -1 and 3 and find the average, the distance halfway between -1 and 3 should give me where my vertex is at. It's just how parabolas look. And that's 1. Yay, 2 over 2 is 1. So your vertex is 1, 8. So let's see what we got here. We've got, let me back up just a hair. Y is equal to a x plus 1 x minus 3. Remember, those signs will flip in here. And I've got a point of 8 and 1 plus 1, 1 minus 3. 8 equals -4a. That's going to come from the, wait, 1 plus 1 is 2, -2, so -4. A is -2. Y equals -2. X plus 1. X minus 3. So again, we solved for A, but in this case, they didn't give me a point. They just give me a maximum value, which is my Y value of the vertex, which happens to be 8. So I split the roots in half, found out that my X value for my vertex should be 1, and then plug that point in, come up with A, rewrite your equation. Remember, if you have any questions, if you want to rewind and watch again, but if you have any questions, if you want to write them down, bring them to class, that way you don't forget them, and we'll see you tomorrow.